Hello, and welcome to a video about Super Factory Manager. I've been playing FTB Skies 2, and I've been using SFM a lot, and I figured I'd share some of the work that I've done. One of the first things that we do when we're getting started is we create a bunch of water strainers. So I have those being fed into some drawers, and the results are being put into a chest where it composts the rest of the materials that aren't aligned in the drawers. So all the pebbles are getting put into compacting drawers. So in this program, every 20 ticks, if the chest has nothing in it, then we're going to input from the strainer and output to the chest. So when there's items in here, it's going to stop collecting from the strainer. And that's to prevent it being backfilled and then trying to do a bunch of move operations that won't fit. So reducing lag by checking if it's empty. So once we take the items out, we see all the items are moved into here. And the second phase of this I had turned off. So if the redstone is greater than 0, it's going to input from the chest, output everything to the drawer that will fit, and then it will output the stuff to the compost multiple times in a row to instantly fill the compost and create bone meal. And then it will take the bone meal from the compost and put it into the drawer. So we can see the labels for these. So the first one is grabbing from the strainer and putting it into the chest, and then the second part is reading from the chest and putting it into the drawers, and then the bone meal, and then there's composters in behind here. So if I flick the lever, it will then take all the biological material and compost it, while the rest of it is put into the drawers. And because the drawers are filled, the chest is now full, and it will stop take from the. It'll no longer take from the strainers. So once the compost has happened, I'll just turn it off so that it's not doing the check, because it is slightly more efficient to have it not checking. So now that nothing else is being moved, if we look at the graph here, it's taking about a decent amount of time, and if we flick the lever, this number should be much lower. So while it's idling, instead of putting a bunch of void upgrades on this, I'm just leaving it to be in kind of a stopped state. But we have a bunch of bone meal. And then the next piece is that we want to be sifting material to gain access to metals. So to do that, if we look at the recipes for the sifter, we see that in the usages we can sift crushed basalt, netherrack, dust, sand, and gravel. So to get this material, we're crushing it and putting it into the drawers, and if the drawers run low on a material, it will activate the hammers. So in these chests, it's going to crush the double compressed cobblestone because it takes the same amount of time to crush, but it gives you more resources as it crushes it. So the program here is doing a check for all of the compressors, and for the resources that are low, it will add it to the hammer input and then take it from the output and put it into the barrels, into the drawers. So looking at the code, it's going to input from our cobblestone generator and output to the compressed cobblestone block, which is this one. So over here, in the same drawer that's making the pebbles, we also have a cobblestone generator. So this is moved into the one that compresses it. And if we have less than 40,000 gravel, it's going to input the double compressed cobblestone and output just one to each of the hammer inputs. And then that same pattern is repeated for dirt, sand, dust, and the crushed basalt and the crushed netherrack. And we're getting the crushed netherrack from the output of some of the sifting process, rather than netherrack. We get it and then we crush it. So this comes from sifting the crushed basalt, and we're getting the basalt to crush from a iron basalt generator, so that's outputting directly into a compacting drawer. And then we have a simple clay generator. So because we have access to sand and gravel, we can use a glass jar and input from our drawers here and then output to the jar. And we also have a infinite water source to add the water, and then the jar automator will make this run whenever it's ready. So if there's room in here, then this will begin processing and creating this clay. So once we have the crushed materials, it's time to sift it. So in this chest, I have a kind of preview of the items that are going to be sifted. So we have to fill the sieves, and then we have to empty the sieves to get the results and put them in the drawers. So to fill them, we have the compressed drawers over there, and we're filling this chest. So if the last output spot is not full, so that all the items are flowing into the drawers first and then this chest otherwise, and once the chest is filled, it will stop feeding the sieves so that we don't get material that we don't have a spot for. And that's again to try and reduce lag. So with these slots filled, I think it's slot 50, it will stop putting things into this control chest, but it is backlogged a little bit. So it will take some time to stop. Or rather, the whole thing will stop. So this bottom part is also inside the if statement. So if there's room in the last chest, it will move from the drawers into the control chest, and then from the control chest, it will always leave at least one of each type, and it will output to the sieves. And this is to give a very rudimentary form of prioritization. So if I wanted to be sifting more dust than sand, I can move the dust to the left, and it should cause it to be drawn out first for the amount of sifters that we have. So if I switch this chest, it'll turn on again, and the code will try and have some diversity going on. And once at least one of each type is being sifted, the rest is going to be as prioritized in this control chest. So in the code, it will input retain one each from the control, and this will go in the order of the slots, and then it will output 16 of each to all the sieves in total, and then once that has happened, it'll fill up the rest of the sieves by adding enough to saturate it with 16 items. And the timing on this is every 200 ticks, so it's a little longer. Like, you could do it every tick, or every 20 ticks, but there's not much point if it's something that takes a while for it to work through the 15 items or so that it's moving. So now we've actually ended up filling up our stuff here. I'm not quite sure how these ingots got in there. So I guess our drawers for blaze powder and such are full. So if I slap some upgrades, it should be a little better. And the other thing is that this chest, if I want to move it into the drawer that I just upgraded, there's this empty chest program. So every redstone pulse, it's going to input from the chest and output to the drawers. So from there, this chest into all of these, when we press the button, all this stuff is moved. I don't know what to think about the ingots getting put in here, because that is not the result of sifting anything. Well, I guess it is dust. Sifting dust will give you a lot of that. So because it wasn't high priority earlier, it just wasn't happening as frequently, but now that we're sifting more dust than other stuff, it is appearing. Still have to look into that. So that's the sifting setup, and then this is of course just powered by create windmills. The other super factory manager stuff that's going on here is we have a giant wall of furnaces, so it's very simple. From the examples, the furnace program, so the furnace manager, this is the example one, and if we look at the actual code, it's very similar. I don't even know what I can't remember what I changed. So we have stuff that's going to be smelted. We're going to output 2 to each of the furnaces, and specifically slots 0, so that it's in the input slot. And then we also have fuel that we're going to input into the furnaces again. And then we're taking from the bottom side of the furnaces, which will only let us pull out the outputs, and we're putting that in the results labeled block. So we have all the furnaces, we have our to be smelted chest, and we have the fuel. So the fuel is tiny coal from the sieving operations. So this all outputs these chunks, which are then moved into the drawers so that they get compressed into the variant that can be smelted. And then these are moved over by this program into the input chest. So we'll see here, the items should be flowing in here, and then they're taken into the furnaces. The program to do that, so we're just inputting all the clusters from the to smelt area and outputting 64 each of them into the destination. So in this case, the to smelt is the ones that are labeled over here, and then those are put into the destination, which is the input. And we're also adding the fuel from the far fuel, which is that one, which is coal, and that gets put into this chest, which is the tiny coal, because it's in the compacting drawer. So each one will give us just one item's worth of smelting. So we're inputting from the far fuel and moving it to the close fuel as well on a longer interval. And this was able to easily handle the backlog of stuff that we had smelted earlier. So before I had set this up, it was just filling up the drawers, and then we were manually smelting, but now it's automatically doing it. And this can smelt quite a lot of items. And then it's getting put into our AE system. So we have many ingots now. What else is using Super Factory Manager? So our power generation is lava-based, where we have jars that are being filled with cobblestone, and the jar above the lava with the automator will produce lava and output it to the adjacent inventory. And from there, we're moving it from the jar output tank into the final tanks here. And the cobblestone comes from the drawer on the left with the generator on top. So we're inputting the cobblestone from the barrel and then outputting 8 to each jar. So stopping once each jar is 8. And then we're inputting the fluid from the tank that's adjacent to the jars and moving it to our final tank here. And then we're using that immediately to generate power by inputting from these tanks the lava and outputting it to the generators. So we're inputting lava from the tanks and outputting to the generator. And then every tick we're moving the power from the generator into our cube. So our cube is located all the way over here. So this is kind of the central buffer of the base right now. And it's filled. And that is powering the applied energistic system directly, because I had a problem with Super Factory Manager not wanting to power the energy acceptor directly. So I will look into that. And then this one is also just powering some stuff. So there's the battery and some other generators and things that are labeled as needs energy. So the things that need energy, this program will move the power into them. So we're inputting from the generator various sides and outputting into the battery, and then from the battery we're outputting to things that need energy. So these are just some quest rewards that we got, these solar generators, which are producing a non-zero amount, but it's definitely not as much as the magmators. So these are doing 4K a tick, some of them, the more upgraded ones, and then the lower ones are only 100. But it's idle power, so it's great. And that got slightly reduced in the numbers, I think, in the most recent update. And then for the applied energistic system, we are creating some of the circuits. So this is a contraption that does that, where there's an input and an output chest. So if we put gold in here, this will be turned into the logic processors, and same thing for diamonds and the other materials. So if we put a bunch of diamonds, I just move all this stuff out of my inventory. And this is taking from the source and outputting to the inscribers for silicon, gold, diamond, and the Certus quartz, and then the last step. So in here, we input from the source, and we output the various items into each of the inscriber that needs it in the second slot. And then we're feeding the inscriber's power using Super Factory Manager as well. And we collect the partial results and we put them back in the source chest. So the ingredients here, the printed processors, not the final step, but the intermediates, go into here, and then those are drawn into the final stage. So we input the processors except for the printed ones. So this is not the so it's inputting the resulting materials, because all of them have the word processor in it, but only the intermediate ones have the word printed in the name. So those goes to the destination chest. And then, so we empty the inscribers here, and then we place the final craft in the last one named last, where we're inputting from the source. And then we're outputting redstone, and then one of each printed type and one of the silicon ones to each of the last ones. And that will, over time, create our processors. And this is quite easily expandable, where we just have to add more inscribers. So if I have a inscriber on me, then just need the inscriber and one of the presses. So I think I have some spare silicon presses. Can pull the labels, and then Alt right click to pick the label, so we can rotate between the ones that are right here versus the ones over there. So we add the inscriber and the silicon label, and now this should be making silicon for us. So if we add a bunch of silicon into the system, that inscriber will now participate. So we make all the intermediate parts and then we make the last part, and then that ends up in our result chest. So this can later be replaced with an ME interface to import it directly into the system, but for now, this is quite easy to do manually. And before we have the applied energistics auto crafting set up, this is great. And then for the Mekanism machines, there's some of the chemical stuff going on here. So if I want to make whatever the alloys are, if I get a bunch of osmium and redstone, then to make the thing, it takes redstone. So to make redstone efficiently, we can add the enriched redstone. So if I want to enrich some redstone, I can put redstone inside the enriching factory, and that will be moved into here, and then the results will be moved into this output chest. So this output chest is shared between all of these machines and all of these ones as well. So these also go to the output chest. So as this creates it, it will end up in this chest, and then that gets imported into the applied energistics system. So we're in the middle of transitioning here. If I shrink myself down, we see that there's a manager here, which is inputting from results and moving to the interface. So we have an interface here that's touching a cable, and then this cable below wraps around till we get out here, where we can then touch the results block. So this is moving into the interface. So all of this enriched redstone is now inside here, and we can place that inside the chemical regions. And once we add a bunch of things to be processed inside the factory, this will be kept in check. So the stocking operation is if the metallurgic infuser for redstone has less than 200 of the redstone chemical, we're going to input from the regions and output to the redstone machine, and then we do the same thing for the diamond one. So I only have 2 of them set up, one for redstone, one for diamond. But it's working quite appreciably. So once the redstone gets low enough, it will add a bunch more. So it keeps it stocked without requiring it to be entirely full. And then those materials are just sent over here, so whatever that makes. I think we just made a bunch more infused alloys, or the control circuits take the osmium and the redstone. So there's something similar is happening for all of these machines here, where we're inputting from the source and outputting to the machine. We do that for each of them. And then from each of the machines, we're outputting those to the results. So we're using a different label here called machine. So this is a crusher, but it's also a machine. This is an enricher, but it's also the machine. And then each of them have a uniquely named source chest, which is being used to input into them. So we have saw source, so this chest is missing a cable. So now that will work. And then we do the same thing here, where we have source and destination for 1 to 6. And then all of them are also named destination. And then these machines receive power. So for each block labeled has power, we're inputting all the energy, and then we're outputting up to 1 million to each needs power block, because with all the energy upgrades in here, this holds 200 million forge energy, whereas our battery is like smaller than that right now. So we don't want to have all the machines be choked out until we fill this one up. And the other thing that's going on is we're also automating power, or Powah. So each of the energizing rods has a energy cube, and this energy cube is kept in stock from the cube over there. So we input from the cube and then we output to our buffers. So those buffers feed the lasers. And if the orb is empty, then we check if we have an emerald, and if we don't, we'll do diamond, then blaze powder, then the iron and the gold ingots. And then we output from the bottom side of the orb, which will only let us draw out the results of the crafting instead of the ingredients. So if I go grab some of this blaze powder, I'm going to put this in here and it will automatically start crafting. And if we add some diamonds, and I think that takes priority. So now it'll craft the emeralds, and then once the emeralds run out, it'll do the diamonds. And these are just being put in the chest right now, so that could also be changed to dump into the applied energistic system once that's ready. I think that's... Oh yeah, I forgot about this area. So here we're making obsidian using the fire essence. So the fire essence can be crafted to make magma blocks by adding it with stone. So we just input a bunch of stone in here, and then once the magma blocks are gone, it will craft new ones. So it's out here to make, if we have less than 64 magma blocks in our chest, we're going to add from the chest and we're going to output into the crafter the stone and the fire essence. And then once that happens, it will, once the ingredients are added, that triggers the redstone pulse using a comparator, which will feed and start the craft. And that outputs right back into the chest. So inside here we see that the part in there responsible for, it's a sided block, so that part shows it, that it's going into the chest here. And then to make the obsidian in the program, if we have less than 64 obsidian, we're going to input the magma blocks and output one to each of the depots, and then we're going to input the obsidian as the result of that. So if we take this out, then those magma blocks are then placed here where they get washed by create. And that turns it into the obsidian blocks. And then we have more Ars Nouveau. So for the to generate source, we have the imbuement chambers that get fed with the logs from the blazing archwood saplings because they give the most. So each of these bonsai pots is outputting into this chest, I believe. So it'll stop once we have 640. It'll start to backlog the pots instead of moving it into the chest. And then those logs are taken from the chests. So we input the logs from the chest and we output to the pedestals. So each of these will receive the logs, and then that gets taken by the volcanic source link and made into source, which is then taken from the relay splitter and put into the other source jars around here. And the floor here is all made out of cables. So these are camouflaged. And if we look at the top part, we see that it's cables that are facaded. So anything touching this is able to be automated. So for the imbuement chambers, this just takes lapis and then makes source gems out of it. So if we decompress some of this, this will be turned into the source gems. And then this one is taking those source gems to make the fire essence. So we're inputting source gems into the chamber, and then we take the fire essence and put it back in the chest. So if we take some of these source gems, and this one is running constantly. And then those fire essences are used over here to make the obsidian. That's kind of the main stuff that I've got going on right now. Just nice to be able to play with the mod and find the rough edges. One thing that I have noticed is that the setup with the power here, where some of these inventories are using this battery, if I were to move this, then that would break multiple of the programs. So something that I'm looking at is having one spot that's pushing the energy into a closer location, and then these ones are taking from that closer location and putting it into the other ones, and that will decouple some of the programs. And same thing with the feeding into the applied energistic system. I think it'll make sense to have the manager here where each of these, it can go out and we can label the ones that are to be drawn in, instead of having each of the ones over here be responsible for pushing into that one. If there's one manager responsible for it instead of many, then that just seems like a simpler approach. So in summary, we're crushing a bunch of stuff, turning it into the chunks, and then those get smelted over here, and then they get fed into an interface and put into the system. And that is getting us our resources. And now with the processors automated from AE, it should be easy to continue to expand the base. Have a good one.